Hello everyone, this is Shravati working as an assistant professor in the Department of Information Technology. Today we are going to deliver on the topic of link state routing algorithm on the basis of design thinking based delivery. Our student Samraj, Sabarish, Harish, Karthikeyan, Karthik will going to deliver the topic on link state routing algorithm.
Hello everyone. Today's topic is link state routing, which is concept of 6 stars. It is also said as using flood to find the distance. The diagram consists of 6 nodes. They are R1, R2, R3, R4, R5, R6. Next topic is explained by Sabarish.
The distance between R1 and R2 is 6. And the distance between R1 and R2 is 3. In the same way, we need to find each root node and each distance between them. So, the adjacent node for root node to R2 is R3. R4 and R1. The distance for each are the adjacent node for R3 is R1, R5 and R2. And the distance between them are the adjacent nodes of R4 is R2, R5 and R6. The distance between R4 and R2 is 7. The distance between R4 and R5 is 1. The distance between R4 and R6 is 8. Now let's take the root node as R5. The adjacents of R5 are R, R3, R4 and R6. The distance between R5 and R3 is 9. The distance between R5 and R4 is 1. The distance between R5 and R6 is 4. Now let's take the root node as R6. The adjacents of R6 are R4 and R5. The distance between R6 and R4 are 8. And the distance between R6 and R5 are 4. Now the final routing will be set by
I'm going to find the routing table for R1. Now we are taking R1 as a source node and we are going to find the adjacent distance of each node from source node. First we are taking R1. It is a self node, so the distance of the R1 is 0 and the next is R1 is 0. Next we are going to the adjacent side of the R1, which is R3 and R4. Now we are taking R3 first. The distance between R1 and R3 are 3. So we are taking 3 as the distance and the next node as R3. Next we are taking R2 as R1. We are going to find the distance between R1 and R2. Now by directly we can see that 6 is the distance, but we need to take the shortest distance. So So we are going from R1 to R3, next from R3 to R2. R1 to R3, from then R3 to R2. So the R1 and the distance between R1 and R3 are 3. Then the distance between the R3 and R2 are 2. So 3 plus 2 is equal to 5. So we are taking 5. And the next node is R3 because it acts as an intermediate between R1 and R2. Next we are taking R4 as the next node. To find the distance between R1 and R4, we are going through the R1, R3, R2 and R4 because it is the shortest path by which we can find the distance. So the distance between R1 and R3 is 3, R1 and R3 is 3, then R3 and R2 is 2, then the distance between R2 and R4 is 7. So it will be 12. And the intermediate for the R1 and R4 are R3 and R2. Next we need to find the path for R5. So we are taking R3 as an intermediate and we are calculating the distance. So from R1 and R3 is 3, R3 and R5 is 9. So 9 plus 3, 12. And R3 acts as an intermediate between them. Then we need to find the destination port, the last node. So we can go to the destination node can be calculated in a different way. Because, for example, we can take as R1, R2, R4 and R6. By calculating this, R1 and R2 will give 6. So R2 and R3 will give 13. 6 plus 7, 13. By 13 plus 8, 21. Which will be higher compared to the another side of the network. So we are taking R1, R3, R5 to reach the destination R6. So eventually we will get R1 plus R2 is 3 plus 9, 12. Then 9 plus 12 plus 4, 16. So it will be the shortest path compared to the another one. Thank you. And the conclusion will be said by Karthik.